This is the first video of a series of videos where we are going to try to graph quadratic functions in general. Quadratic functions of the form ax squared plus bx plus c, no matter what a, b, and c could be. Now our strategy will be, a quadratic function can either be something like this, or maybe something like this. It depends on the concavity. But the first thing we're going to look at is the y-intercept. So this quadratic function, if there's a y-axis here, it's going to intersect the y-axis somewhere, always. X-intercepts, this is where we intersect the x-axis. So if the x-axis is here, I would have two x-intercepts. However, it's also possible for a function to not have any x-intercept, either if it's because it lies completely above the x-axis, or it could lie completely below the x-axis. There's always a y-intercept, but sometimes there aren't any x-intercepts. So this is when f of x is never equal to 0. So for finding the y-intercept, we just evaluate f of 0, right? Because this intercept here is when x is 0 and its y value is f of 0. So by evaluating f of 0, we find the y coordinate of the y-intercept. If we solve f of x equals to 0, so by making, right, ax squared plus bx plus c equal to 0, we are going to find the x values that make the y value equal to 0. So it's those guys we want to find, right? The maybe a first x-intercept x1 that we need to find, but with a y coordinate of 0 because it lies on the x-axis, and on the x-axis the y coordinate is 0, and maybe a possible second x-intercept like this. Oh, and I didn't mention it, but it's also possible to have a parabola that just touches the x-axis, in which case you'd have a single x-intercept. The other thing is that these parabolas, they have what we call a vertex. So this is the lowest or the highest point on the parabola. So this would be the vertex. And this would also be the vertex here. And finally, we're going to look at the concavity of our parabola. And as explained before, that's determined by the sine of a, which is the coefficient of x squared. So if a is positive, it means that implies that the graph will be concave up. So this is the case here. In my first example here, this is a parabola that's concave up. And if a is negative, it's concave down. If a is 0, we wouldn't be having a quadratic, we'd be dealing with a linear function. So we're going to assume a is non-zero here. Okay, so let's start with our first example. So the function is 2x squared minus x minus 3. So let's go by little steps here. Y-intercept. First of all, we're going to evaluate f of 0. Now that's pretty easy for a quadratic because basically f of 0 is the constant term. So here minus 3. So this implies that 0 minus 3 is the y-intercept. Now let's look for x-intercepts if possible. Now what we are going to do is we're going to solve f of x equals 0, which means solving 2x squared minus x minus 3 equal to 0. Now that should remind you of things you've done before. So we're trying to solve a quadratic equation. what's our first tool? First thing you should try is factor. If that doesn't work, then you can rely on the quadratic formula. But I would say factoring is a lot easier if it can be done. So what are we looking for here? A product of -6 and a sum of -1. Yeah, that can be done. -3 and 2 will do. So we split the middle term. We split them because the coefficient in front of x squared is not a 1, it's a 2. So I need to do factorization by grouping if I want to get this done. So you see there's a common factor of 2x minus 3. So this is x plus 1, 2x minus 3 equal to 0. So which means what? X is either -1 or 2x minus 3 is 0, which means that x is 3/2. So I have 2. So that means that -1, 0 and 3/2, 0 are the X-intercepts. And for concavity now, oh, actually I forgot, there's the vertex. Now what's the vertex? So that only works for a parabola. When you have a parabola and you've got two X-intercept, the vertex is right in the middle. So in the middle of the X-intercepts. Now that only works for parabolas, for polynomials of degree 2. You could have other types of functions, you know, that go like this maybe, okay? And you can see here that the vertex for that curve is not halfway between the two X-intercepts. But for a parabola, that's always the case. So how do we find the vertex? Well, notice that this is going to be 3/2, 0 and -1, 0. So what's the middle of the two x coordinates? Well, think about taking the average of the x coordinate to get what's in the middle. Okay, so in the middle here, this is going to be the average of the x coordinates of the X-intercepts. Okay, so x here is going to be the x value is going to be, I'm going to take -1, which is the first x coordinate, which is the x coordinate of the, let's say, the first X-intercept. The second X-intercept has an x coordinate of 3/2, and I take the average, I divide by 2. So what is that? This is a half divided by 2, so this is 1/4. So that's the x value. What's the y value? The y value is going to be f of that x value, f of 1/4. So if I replace 1/4 into my equation, 2x squared minus x minus 3, so 2 times x squared minus x minus 3. So what is that? That's 1/8 minus 1/4 minus 3. I put everything over a common denominator. Over 8. So this is minus 25 over 8, like this. So the vertex is going to be minus 1/4 and minus 25 over 8, which is a little under minus 3. Okay, so now I'm ready. Well, in concavity, maybe very quickly. Concavity, we see that the coefficient in front of x squared is 2. So here is 2, which is greater than 0. It means that the function is going to be concave up. So I've got all the ingredients now to sketch the graph of this function. Okay. going to sketch it like this. Okay, so I see that, so I want to indicate the vertex, the x-intercepts, and the y coordinates. So I have to adapt the scaling of my axes accordingly. So I know that I'm going to have an x-intercept at -1. The other one is at 3/2, so it makes sense to divide it this way. So this is 1, this is 2, this is -1. So I'm going to have an x-intercept here, another one here. So this is okay. So I've covered basically the range of along the x-axis for my parabola, so that I can at least identify where the x-coordinates are going to be. The y-coordinate is at -3, so this is definitely something at this is definitely something that I want to indicate here. And I know my vertex is actually not that far below. It's at -3 and something. So I'm pretty good with my scaling here. Okay, so you have to adapt your scaling so you can see everything. So we can maybe start to identify the important points. So the x-intercepts. You see you don't want to have the coordinates of your point in the way of the graph of your parabola. Okay, so here we're gonna write it to the left of that point. So this is 0, -3, like this. And where's my vertex? My vertex is -1,4, so it's in the middle of these two x-intercepts, and it makes sense. And it's a little bit below -3. It's -25.8 it's -3 1/8. Okay. So this is my vertex here, -1/4, -25/8. And as you can see now, the graph of my parabola is not gonna crash into the coordinates of the points that I've indicated. So this is, you kind of have to anticipate where the graph of that parabola is gonna be, so that your points are shown clearly on the picture. And that's our first sketch. Okay, so we've got the y-intercepts, the y-intercept, the x-intercepts, and the vertex. So you need to show all these features.